Hello everyone, welcome to this tutorial. My name is Emerson Ahrari, I'm a Google Earth Engine expert. In this tutorial, I'm gonna show you how you can monitor snowy days for a long period of time. This is very insightful and informative tutorial for those of you who want to know how much snowy days shifted during the time. So, first of all, go to Search Places and Dataset to find the appropriate dataset. Type ERA 5 product. ERA 5 is one of the most popular product for the climatological studies. It is available with daily and monthly temporal frequency in the Earth engine. As you can see, ERA 5 Land Daily ECMWF Climatry Analysis is available. Import it into the code just like that. Here we have it as an image collection. Make a new variable as ERA equals to image collection. Now we are assigning image collection to the ERA variable. So then if you want to know about these data characteristic and properties, go to the data description here, open it up in the new browser page. You can see this data is available since 1950 to 2024. This is a very valuable product for a long-term daily analysis. Spatial resolution is around 10 km that is suitable for global analysis, and also several bands available here that enables us to have access to a very big data set regarding to climatological parameters. For example, in this tutorial, the snow cover is my target, and I want to show that how snow cover days or snowy days changes from one year to another year. So as you can see, the snow cover based on the percent is my target in this tutorial. So a snow cover is the target band, and you must copy and paste it into the code. Back to the code in the JavaScript here, and then select the target band using the select. As I mentioned earlier in the previous tutorial on my YouTube channel, the select is a function allows us to select a band. So dot select, the target band is the snow cover. Dot filter date. Now you must actually filter your data based on a period of time. For example, for the last 20 years, from 2000 to 2024, for example, 24 years, I'm gonna see that how much snowy days varies from one year to another year. So start equals to 2000 and ends equals to and ends to 2024. 24 years data with actually daily temporal frequency, and it's a snow cover. Now make an average map using the ERA layer, because we want to get understanding about the type of data in this product. So I'm gonna make an average map using ERA mean, a new variable equals to ERA.mean. The mean or average map allows you to get the average of a snow cover for each pixel during the time selected here. Starts from 2000 to 2024. No need to any filter bound, because this is of course a spatial resolution satellite data, and also it doesn't have framing structure, so we don't need to use anything like a filter bound here. So for the visualization, use map.add layer here. This is ERA average. No need to clip it based on the region of interest, and leave the visualization parameters empty now. And now the layer name equals to the ERA mean, and use the false at the end to avoid actually automatic visualization. Save your code and run it again. After a few moments, a new layer is created. Check it on, and after a few moments, you can see the average map that is created. We want to use the average map, just get understanding about the variations or characteristic of pixels how the pixel changes, what is the values in the variable, in the average image that is created. So, as we selected a long period of time, getting average is a little time consuming. The simplest way is limiting our data to 1 year. For example, I'm gonna only get an average for 1 year from 2020 to 2021. Run the code, and in this scenario, now you will get the result faster. Check it on again. I'm waiting to see the results. Now you can see it showed very well. When you are using a very big data, then the Google Earth Engine actually the speed of Earth Engine process highly reduced. That's better to actually use the simplest code and also smaller data to make your code faster. There are a lot of methods and techniques allows you to have access to more speed of processing in the Earth Engine that in this tutorial or other tutorials I will try to share their tips. So here you can increase the contrast using enhancement technique. For example, based on 90% of values you can see here, we can increase the contrast and you can see the range of the values ranges from 6 to 61. This is based on the percent. Click on apply and now you can see the average snow cover for the North America that shows which areas covered by actually a snow cover more than the other regions. So after we get familiar about the range of values and we understand it has an integer range of value starting from 0 to 100, now in the next step I'm gonna actually make an annual year map to show you that how many times one pixel covered by the snow, or we want to calculate the snowy days for each pixel in the next step. That is very important. As you can see in the map, we have a grayscale layer. The actually white area shows higher snow cover, the darker region shows lower snow cover. So the threshold to differentiate or separate snowy pixel from non-snowy pixel could be something like 10. For example, when a pixel has value 10, meaning that 10% of that pixel covered by a snow cover, because it has and also, as you know, this data has coarse spatial resolution, and all the information we have in each pixel, it is a mix of different combination. Part of that could be, for example, a snow cover, and part of that could be water, part of that could be affected by different land covers. So that's why we need to use lower percentage to consider to select snowy pixels. So as you can see here, for example, for 1 year I'm gonna do this and show you how it works. So now for 2020 I'm gonna calculate the number of snowy days. I have showed you how to do this in the Earth Engine in my previous tutorials on the YouTube channel, but here I'm gonna repeat it again and show you how we can make a loop based on to repeat that process for each year separately to produce one image collection with such kind of information. So for example, the test variable, the test snow equals to, so from arrow5 dot filter, first bring arrow5 variable includes 365 snow cover layers from the starting to the end of year. So now I'm gonna filter it based on 1 year starting from 2020 to 2021. Then make a function in which each input pixel considered as an img, and now I'm gonna separate I'm gonna separate the snowy pixels and now non-snowy pixels. It's very simple. Dot return. So from each input image, I'm gonna select those of pixels that their value are greater than 10. So now, after the function created, the returned image is a binary image that shows actually snowy pixels with 1 and non-snowy pixels with 0. So in this case, if I get the sum or the total value of 0 and 1 during a 1 year, so now I can see that how much of the time one pixel covered by the snow. For example, here using map.addLayer, I can show you the test snow layer. No need to clip it based on the specific region. This product is global and also has coarse spatial resolution that is suitable for the global studies. So test snow. Just for the visualization, we know that the minimum will be 0 and the maximum will be lower equal than 365, as you can see here, because we have 365 days, and if we assume that one pixel covered by the snow cover for the whole of the year, the maximum value will be 365. So then the layer name is snow frequency, and use the false at the end to avoid automatic visualization. One of the other scenarios that helping you to speed up processing in the Earth engine use the false is using the false at the end of map.addLayer, because it avoids automatic visualization that's highly useful for speed up processing. So save your code and run it again. After a few moments, you will have a new layers. Here, if you check it on, you will have a grayscale image again. And also this is completely same as, and also you can see the same pattern in the average image, but the values are different. For example, if I click on one pixel, here you will see that the snow cover will be 241, meaning that during 2020, this pixel experienced 41 days with a snowy situation. So that's the type of information we want to get from the snow cover frequency layer. For example, this pixel only experienced or covered by snow for 29 days during this year. So now I'm gonna make a loop to repeat this process for each year separately. And now at the end, I want to have a history of snowy days from, for example, 2000 to 2024. As you can see, already we selected the snow cover and also the period of time, and everything is stored in the era variable. So now I'm gonna make a function, actually make a list, and then I'm gonna filter my data based on annual delta time, and then do the same process for each image. So it's very simple thing. Now I'm gonna making a new variable as actually list equals to earthengine.list.sequence. In order to get difference between the start and end date, I'm suggesting to make two different variables as time start and time end. Here, a new variable as time start, because I'm gonna have the start date with the date format, because I need to get their difference in the next step. And then time end equals to earthengine.date, but this time for 2024, just like that. So if you want to get the difference, so here we will have the difference time end dot difference. The difference is a function that helps you to get the difference between two times with the diff based on different units. As you can see, the difference including two arguments. One of them is a start and one of them is unit. A start equals to time start and the unit will be day, because we want to get differences based on the number of the day. If you want to get the differences based on the month, you can use month here. So here I'm gonna get differences based on the day. If I print the time difference, you can see that time difference. In the right panel under console, you can see that 8,766 days actually difference we have between time end and time start. So now I need to make a list based on these days. But the unit here is based on the annual format because I'm gonna have one image for each year separately. So now I can change it to the year and you can see that we have 24-year difference. But the value should be round here. To round the final value, use the round function. Round and run it again. This is the integer value as 24. So now I'm gonna make a list with 24 rows or 24 records. So the list is starting from 1 and ends to time difference. The length of the list is defined based on the time difference between time start and time end. So here, and then I'm gonna make a function because I'm gonna actually enter the date of each year separately for each record. For example, if you can see, we have a list of numbers starting from 1 to 24. Here it is. Let me skip the print here. We have a list only including integer values from 1 to 24. So now I need to have the start date instead of 1, 2, 3, 4, 5. For example, instead of 1, I'm gonna have January 2000, January 2002, January 2011. I'm gonna replace the values with the start dates. So here we need to make a loop using map function. So now to apply the target calculation, make a function here just like that. And also each input record consider it as an I here. So you can choose any other name if you want. So the function returns EarthEngine.date from YMD. When you want to make a date manually in the EarthEngine.date from year, month, and day is useful. So the start year will be 2000, January 1st, 2000. Skip the time zone, and now dot advance. I'm gonna start in the list from January 2000 until the end. Dot advance, we want to go forward during the time based on the delta. The delta is actually the value we have here. 1, 2, 3, 4, 5, as you can see. So, and the unit is based on the year, and skip the time zone again. Run a code again. Again, we have a list starting from 2001 and ends to 2024. That's how it looks like. So we have the start date, and also it's a good situation in which we can actually filter out our data based on each year separately. So here, just make another variable. This is annual frequency. Annual frequency equals to. So under annual frequency, bring the list that included starting date already. So then we want to do some sort of calculation based on. So for each record separately, we need to make a loop here that map each input record that is equal, make a function first, each input date here from each record considered as date, or you can choose any other name that you want. So now a new variable created as a start date equals to importing date considered as a date with the date format. Now we have the start date and we need to have the end date too. End date equals to from start date dot advance. From start date we want to go forward with 1 year difference. Let's give the time zone now. So now we have the start date and end date. This is a good time to filter out our data. I mean the era data now could be filtered out based on each year separately. So make a new filtered collection equals to from input image. So the input image collection will be era here. Each time for each record I'm gonna filter data based on new start date and new end date. So after the start and end date is created, I'm gonna do a specific or a very special or particular analysis only for each year separately. How to make it? It's very simple. Now I'm gonna make another function inside of the main function. I'm gonna make a new loop inside of the existing one. This time each input image considered as an IMG, and now I'm gonna calculate from each input image. I'm gonna make a binary image from each input image, those of based on the pixels greater than 10%. So then after binary images created for each year, I'm gonna calculate their sum. Here it is. So the filtered collection or annual, here we can add another name. I think another name could be annual snow or annual, yes, annual snow is good. Annual snow frequency is created, and finally the function returned the annual snow as a final result. But the problem is the input image was actually the input collection was the daily had the daily frequency, and the output now has the annual frequency, meaning that we need to make new system time start and system time end in the property layers. Here I'm using that set to make a new property or new system timer start. New system timer start equals to start date, because start and end date already created, but must be converted to the millisecond format, and then use the dot set again, this time for system time end, and end date dot millisecond format. So just like that, and we must convert it from the list structure to image collection structure. Bring whole of process in the image collection. I'm printing annual frequency, just like that. Run a code again. In the right panel, we have one image collection with 24 elements. So here, open it up, and you can see for each year we have a new image. We have one annual image. Maybe the data is not updated for last year, so we can, for example, reduce the last year to 2000 23. So as you can see now, the data are completely available until the end of until 2023. So there is no problem for the actually image collection. So as you can see, for each year we have one snow cover layer that shows the frequency of snowy days with the new properties as system time start and system time end. And also it is possible to add a new property as date that shows the date information with normal format, because the millisecond format is actually the suitable format for the Earth Engine time series analysis, but for the users it is difficult to read these values. So that's set, not chart type here, that's set. I'm gonna make a new variable, a new property as date. This time start date will be in a string format using dot format. Just I'm gonna see the year for y, meaning the year here. So run the code again. In the right panel, we will have a new property. For example, this is for 2022, and the first one is for 2021. You can see the start year here. As you may notice, there is a problem in the collection list created. The starting year here is 2000, but the first image is related to 2001. The first year is missed. The problem is related to the starting number into our list. The value should be started from 0. Now click on run, and we have a list with 24 elements, as you can see, starting from 2000 to 2023. If you go to the image collection here, the first element is for 2000 and the last one is related to 2023. Now the code working very well and there is no problem. So, and also as you saw here, the sum of the frequency for a snow cover or a snow cover frequency for each year calculated. And now I'm gonna visualize it through the map.add layer. Couple of arguments we have here. The first is the annual frequency, and I need to have each year frequency under a single layer with image in image stack format. Leave the parameters empty because the input is a multi-band image, and the layer name is snow frequency collection, and shown equals to false, and skip the capacity. So run a code again. Here you will have a new layer as a snow frequency collection. As you can see, from 2000 to 2023, all the data are available. For example, for 2013, I need to know that which pixels, how many days each pixel covered by the snow cover. Click on apply. After a few moments, you can see here through the inspector, if I click on a pixel for this year, you can see that this is the variations of that pixel, but here you can see this pixel how experienced snowy days from 2000 to 2023. And also there are simpler way to actually monitor the snowy days for each pixel separately. And also here we can use we can use the user interface chart. Print using user interface chart image.series. It is very simple. For example, first you need to mark a pixel. I'm gonna mark a pixel here, and then the input image collection will be annual frequency. The region equals to the point or geometry. The reducer Earth Engine.reducer.first it will be that first here, because I'm gonna get the first value touched by the geometry in this location. The scale equals to 10,000 because the spatial resolution is 10 kilometer. 10,000 here means 10,000 meter equals to 10 kilometer. System time starts and run the code. In the right panel under console, you will see the variations of snowy days for the selected pixels from the start to end. As you can see, from 2000 to 2023, you can see the fluctuations of snowy days over the 24 years. For example, now we know that in 2019, this pixel experienced the most snowy days over the last 24 years. And also we can do more. For example, our data set actually covering different data since 1950. I can increase the time, the period of time we are working easily by changing time start. For example, I can start from 1990. Here we have 34 years. And also here that show, but this is a start from 2000. That's why, because this is here, here the date starts with 2000. We can change it to 1990 and run a code again. And but still the same problem. Let's see what the problem is. The time difference is 34, starting from 1990 to 2003, and here we have a list with 34 record comes to the start date, end date, and then for each year the data is filtered out based on, oh yes, that's a problem. The time start and time end should we need to rewrite the filter date based on new time start and time end. That was my fault, sorry. It's very difficult to find the issues and debug the code same during the tutorial making. So as you can see, now we have the variations of snow cover since 1990, and I can also increase it to longer period of time from 1970 for 54 years now. And still there is a problem because I need to change it from here, from 1970. Chart is under generation. This is the process from 1970, or we can start it from 1950, again 1950, and run a code for 74 years. It's awesome for long time data analysis to see that how much snow cover varies over the last years. As you can see here, over the last 20 years, we were experiencing lower snowy days compared to the longer period of time since 1950. It's very, very important and valuable analysis in the Earth engine that help us to get a better insight about the variations of snowy days for all around the region. It should be noted that this product is easily and simply and freely is available for all the users, and also it has global coverage. You can use it for your own region, and the code link is available below the video in the description box on my YouTube channel, and you can ask your question. Please put your comment there and I will try to answer your questions as soon as possible. Thank you for your attention.